Okay, so here is page 2. Let A, B, and C be positive constants, so they're just positive numbers. That way nothing goes all wonky with the negatives. What is an equivalent expression to log of all of this? This would usually be a multiple choice because there's lots of different ways we can write this, but let's split the whole thing up. So we have 3 different terms in here. So I have this A term, I have this B term, if I can get this B squared term, and then I also have this C to the 3rd term here. So we're going to write a log function for each, or a log expression for each one of those. So we will split this all up. So these top 2 are multiplication, this bottom one's division. So this will be log of A to the 5th plus log B squared minus log C to the 3rd. And we can see here that there is my A term right there. Here is my B term. Both of these are positive logs because they are on top in the fraction inside the log. And then since C is on bottom, it is a subtraction. And then we could take it one step further and we could pull the powers out of each one of them and make them coefficients. So we end up with 5 log A plus 2 log B minus 3 log C. And that is the equivalent expression. There we go. Okay, next one is also calculator active again. So the function f is given by f of x, is that right there. The function g is given by log 3. Rewrite of 81x. Rewrite the function using the properties of logs and explain the transformation from f to g. So we want to know the transformation from f to g. So transformations, that's just, we need to make sure that these functions are the same. So I want to get, ideally, I want to get log 3, or log base 3 of x looking like this right here. So I need to find a way to get that 81 out of this log. So let's see here. So g of x equals log base 3 of 81x. So I need to get this 81 out of here. So this log 3 of x looks the same in both. And then I can see the transformation based on what's left over. So this is multiplication, 81 times x. So we can split these the same way we split them up here. And I can make this log 3 of 81 plus log base 3 of x. And then I can rewrite 81 as a power of 3 with a base 3. So this will be log 3 of 3 to the 4th plus log 3 of x. Now if you notice that log 3 of x and log 3 of x are the same here, so we want to leave that alone. Now that they're the same, we can compare them a lot easier. So then this is going to be the same. Now these cancel out. So this is going to be log 3 of x plus 4. So that 4 is what stays. And so from f to g, f is shifted up, 4 to create g. So this is on the outside, it's addition, so it's a shift. And there we go. Didn't actually need a calculator for that, but you can. If you want to do log base 3 of 81 in your calculator, totally fine. Using tables below, determine if the data given is exponential, logarithmic, or linear. So we explain our reasoning. So here we're going to check to see what is the jump from one to the next. So this one is +2, +4, +8. So that one is not quite, so this is not a constant. Here this is just +1 each time. So when y is +1, it's either going to be, or when it's y is plus a constant, it's going to be a linear or a logarithmic. And then here it's the second difference. So this is what, 2, this is 4, and this is 8. So that's the first difference. And then if we did this, the ratio, this is times 2, this is times 2. So after the first difference, there's a times in there, so this should be logarithmic. And then here, this is +1. So the x values are a constant difference. And down here, that's times 2, times 2, times 2. So these are all proportional. They have a common ratio. So this is going to be exponential. And then C, so these are all +1 again. That is a common difference. And then here, this is +4, +4, and +4. So equal intervals over x, equal intervals over y. That means that it is a linear function. Great. One more on this page. The function f is given by that expression there. Find the information below for f. So an asymptote. So logs are going to have a vertical asymptote. And the vertical asymptote is usually at, or its parent function is going to be at, a vertical asymptote, so it should be at x equals 0. So anything that adjusts x is gonna do that. And so we look here. So at x equals 0, this is where x is. So 3 minus x is at 0. We're going to subtract 3 from both sides. So you get x equals -3. Divide each side by -1. And you should get x is 3. So we should have an asymptote at x equals 3. So it gets shifted over, and then it gets reflected. Our domain. So our domain is typically 0 to infinity. And as we can see here, the 0 gets switched to a 3. And so this is, and this negative right here is a horizontal reflection. So it goes from being, the domain goes from 0 to infinity. And then with the shift, it becomes -3. Yeah, the shift is just the -3 to infinity. And then the reflection changes it to infinity, which is the reflect, and reflects that side too. So you get infinity to 3. Oh, sorry, -infinity to +3. Next up, the range. Well, this is a log, so logs always have a range of -infinity to +infinity. And then finally, or not finally, the in behavior. So our in behavior, so this is the parent function. That's the parent function. And then what happens is that we go up to, which does not change the in behavior at all. The asymptote, though, does, and the reflection. So this gets reflected around, so it becomes this right here. Actually, we're going to do the sketch. We'll do it over here. So it gets reflected horizontally, so now we have this asymptote here. And this asymptote is at x equals 3. And this is going to go off to infinity in that direction. It's an ugly arrow, but there it is. So our end behavior is as x, so the limit of f of x as x approaches negative infinity, y is approaching positive infinity because it's going up in that direction. And then the other direction is the limit of f of x as x approaches. Now we can't go to infinity because there's a vertical asymptote, so we are approaching 3, and we're going to approach it from the negative side, and it's going to negative infinity. So there is the two ends of our behavior. Scroll up there. Okay, and then I'm going to stop that one there, and we will pick up with the next video.